So today's video is about IDFT, how we perform IDFT or inverse discrete Fourier transform using the algorithms that we have learned so far of FFT. As described earlier, FFT is not a new transformation method but a faster method of computation of DFT. In this video, we will learn about solving computing inverse discrete Fourier transform or IDFT using the same algorithms, that is DIT and DIF of FFT. The equation, as we know, for IDFT is xn is equal to 1 by capital N summation k going from 0 to n minus 1 xk capital Xk Wn to the power nk, that we have already studied or discussed in the DFT chapter. Now, if we multiply both the sides with capital N, what we get is capital N x of n is equal to summation k going from 0 to n minus 1 capital Xk Wn to the power minus nk, where n goes from 0 to capital N minus 1. Now, if we take conjugate on both the sides, we will see that we get n x star n is equal to summation k going from 0 to n minus 1 capital X star k, that is conjugate of capital Xk Wn to the power nk. As we see carefully the right hand side of the equation, we can note that it is nothing but DFT of capital X star k, that is complex conjugate of xk. It is just the DFT of complex conjugate of capital Xk, which we can solve using any of the FFT algorithms. So, what are the steps? There are 4 steps that are involved in solving IDFT using FFT. The first step is to take conjugate of xk. Whenever we will be given to solve IDFT, we will be given a capital X of k. Now, capital X of k, we can transform it, or we can take its complex conjugate, which will be capital X star of k. Now, if the second step would be solving DFT of capital X star k using any of the algorithms of FFT, either DIT or DIF. The third step would be the result we get is n x star n. So the third step would be finding the complex conjugate or transforming the complex conjugate of the result, that is what we will get is nxn. Lastly, the fourth step would be dividing the result by capital N. So what we get is x of n. Herein is an example that has been solved by using DIT. We have performed the IDFT of the given xk. So the first step is taking its complex conjugate, that is x star of k. And as mentioned in the problem, it is a DIT algorithm. So what we start with is x star 0, x star 4, x star 3, x star 2, x star 6, x star 1, x star 5, x star 3, x star 7. And as it is DIT, it would have first butterfly between the two consecutive numbers. And before we proceed, we need to know all the twiddle factors, that is W80, which is 1, W8 to the power 1, W8 to the power 2, W8 to the power 3. All these 4 twiddle factors are found out here in this slide. In this slide, all the answers of the first stage of the DFT or rather we should say the FFT is written over here. For example, the first answer would be x star 0 plus w8 to the power 0 multiplied by x star 4. The fourth answer would be x star 0 minus w8 to the power 0 x star of 4. In this way, the first answer is 8. The fourth answer would be 6. In this way, all the stages, all the answers of the first stage are mentioned or derived herein. In this slide, all the answers of the second stage is derived. As we can see, all the answers of the second stage of the FFT algorithm is derived herein. As it is DIT, we have to note carefully, it is after multiplication of the Twiddle factor and the second term, then only we will add and subtract as the case is. In DIF, first we add or subtract, then only it is multiplication with the Twiddle factor. This slide gives you all the answers of the third stage, which is the final stage, and the answer here is n x star n. So at the end, what we do is we have to divide the answers of the third stage by capital N, in which in our case it is 8, and then take its complex conjugate, and the answer here is 7 ones and 1 single 0. So this is all about IDFT using FFT algorithm. Here nothing new is being done. We are using the same DIT and DIF algorithms. The only change is before performing we have to take complex conjugate, then follow the rules of the algorithm, and at the end we have to divide by capital N and take its complex conjugate. Thank you class. For now this is a shorter video, and next I'll give you some assignment on the chapter of FFT.